Okay, I've taken the time to make a couple of modifications to Franken puller here. I found that if I run the bolt all the way back, that I can actually remove this third link that I had in there, which gives the whole thing a little more stability, I think. And I just tried a quick test fit, and it looks like this is going to work by having. Oh, actually, I think this. I got to flip this around like that, maybe. I think this is going to actually work. The other thing I did was I tightened up these bolts as much as I could, and where there was a huge space, I put a spacer in. I actually could put a couple of washers in here too. I'm just trying to take some of the slop out of this thing, makes it a little more stable. And then I've still got this staggered because, you know, ideally I would have 2 of these here and 2 here. And 2 here and 2 here, but I don't have enough of these plates. And I could make some up easy enough, but I really don't want to go through all that. I'm just going to try and do it this way, and hopefully this will work. It does seem already a lot better than that mess I had on the first attempt. This is still a really weird deal here, how this is not wanting to pull evenly. Gosh. Just when I thought I had something there. Once just pull the whole puller off on this side. This ain't working. These jaws are just not good for this job. In order for this to hook properly underneath the edge of that, this has to be tilted in more this way. The problem is, when I do that, it's actually hitting up against the housing here. So these tend to be in a position where they want to stay stuck out like this. Actually, yeah, I should have took that off a while ago. That also causes this to pivot in, and this whole top part of this to impinge on my whole mechanism, which doesn't help. So I could. This is a cheap made in Taiwan puller. It's a piece of junk. It's I don't even know where I got this one, but I'd be willing to sacrifice this. I might want to just cut this right here. So I just got this little part of the puller to deal with, to hook onto. But that's still not going to solve my, even if I do that, that's still not going to solve my problem with the angle being all wrong here, where it keeps impinging here. What I need is I need something other than these jaws to grab onto. I guess what I'm saying is I want to use this part of the puller without these jaws. Come up with something else to grab this. I wish I had some chain. Those of you who are thinking to yourself, oh, the way you do that is with some chain, because I've actually seen others use chain. I think what they do is they actually get the links of chain to go down through here and then come up on the other side, fish it out on the other side, and actually the chain will actually be grabbing around this like truss part, which actually is a lot stronger. So I could see why they would want to pull it from that. You know, let me think about this off camera. Maybe I'll get lucky and the wife will call for breakfast before I have to do this. Oh, okay. Took some searching, but I found a length of chain here in the shop. And the links on this should be strong enough to pull this, but they're still small enough that I can get them down in there. And what I can do is I can get them down on one side, reach in there and fish them out on this side, and pull them, so that when they come up, I can have one of these links actually straddling the bottom of this carrier truss on one on each side, and then have the links come up and join each other with a bolt. So that I think is going to work. So I'm going to cut this chain into 2. Now I want to cut it into 2 even pieces. I also want an odd number of lengths. Why an odd number of links? Well, because if this is going to be my one link that's going to be underneath supporting, then I want an even number of links on each side of it coming up. So that's where I get my odd number. And then on this chain right here, for some reason, I don't know what's going on this chain, but we've got a bad link right here. It's actually very deformed and stretched. And even if that's still strong enough, the problem is it's going to cause a discrepancy in evenness of the length of each side. So I'm going to lose a couple of links because I'm going to cut this one off. And then I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 left. If I cut that in half, I'll lose a link where I cut it. That'll give me 11 links left. Right now, I don't want to do that. Now, there's several ways to cut chain. Bolt cutters, hacksaw, grinder with a cutoff disc, any number of different ways. And sometimes it's just faster and easier to go real old school and do something like cold chisel. It occurred to me that maybe somebody would want to see how easy it is to cut chain links with a cold chisel. And yes, I am wearing safety glasses. The link on this side is not flat. That is why this is uneven. Should be able to jiggle this thing into position. Alright, right now I got quite a bit of tension on here and it's not budging, so I'm going to tap around the outside of the case. It's all off kilter again. This isn't working. Well, alright, I'm going to have to give up on that whole idea. I've seen others do it, but I wasn't able to pull it off, pardon the pun, using the chain method. So I think what I'm going to do now is I've got a milling machine, so I don't see why I shouldn't just make some jaws that will fit in here properly and can adapt to my current puller. So in the meantime, I'm going to put some penetrant around this edge here and let it soak in. This is liquid wrench. This isn't, in my opinion, as good for this kind of a job as, say, like PB Blaster, but I really don't think it's going to make much of a difference. And I have a lot of this stuff. So, and it does say freeze rusted bolts and parts, so no harm. And since I've got so much of this stuff, I can really be liberal with the application and leave it to soak while I contemplate and build my puller jaws. All right, I think I'm going to be able to turn these two pieces of scrap into some pretty good pulling jaws. I don't know, you wouldn't think it looking at it. Well, first thing I'm going to do is I'm going to face one end of each one of these before I cut them to length. First operation I want to do is I want to put a flat on this, and I want it to be the dimension from the back side of this to the flat to end up being 650 thousandths. This is 3/4 inch stock, so it makes it pretty easy. It's I'm going to take 100 thousandths off. The other piece that I cut is actually a little bit different diameter, so I'll handle them independently of each other. But anyways, so 750 thousandths. So I've got my V blocks on the side there, and I've got this clamped in the vise. And how far this sticks out, I want to keep that pretty much uniform on both of these that I do. So all I'm going to do is I'm going to use the edge of the vise here, and I'm going to use the depth finder on the digital calipers here, and I'm going to figure out what that's at. It's at 1.135. Thinking I might want that to stick out just a little bit more, maybe. I'm going to go with 1 1/4 inches, 1.250. So I'll just lock my calipers at 1.250. Loosen this up. Take a 50 thousandths cut. manually stopped at 0 so that I'll know, I can just count how many revolutions I've got to go back, and then I'll know the total distance I went. So I'll take all the way to 100 thousandths. I don't need a really smooth finish on this. So that's going to be 100 thou. Now I'm going to make a slot a 1/4 inch deep, and I want to make it up from the bottom probably about 1/4 inch, so that I leave a little metal lip here that's going to be what's going to grab onto that. Yeah, maybe I even want to get a little bit heftier than that. You know, I'm going to go with a 1/2 inch. So for starters, I'm going to unlock my knee, and I'm going to come up the 1/4 inch. So that's 250 thousandths. Roughly there. And just touch it off on the end of that. Now I'm going to move the cutter over, diameter of the cutter, this should be a 1 inch cutter. Oh no, that's a 3/4 inch cutter, isn't it? I thought I had a 1 inch end mill in there. Well, that's a 7/8 cutter. Guess I shouldn't assume. Okay, so I'm going to move the table over 875 plus 500. There we go. That's where I want to be. That should give me a 1/4 inch deep, 7/8 inch wide groove, 1/2 inch up from the bottom. This would be the bottom here because these are going to be vertical when they're being used. And so I'm just going to feed this manually. I'll let that cool off, and then I'll do a test fit. Alright, I just got rid of the burrs on it using my wire wheel, and the test fit's good. So you see, the reason why I milled this flat was to get this diameter down to a point where it'll fit in there. Okay, and then I've got the groove in there, so once I put this down in there, I can bring this over, and that 250 thousandths wide little shelf right here is going to grab this outer ring. Alright, so I'm going to make the other one the same way. I'm going to have to take a little more off the other one because it's a little bit thicker, I think. And then what I got to do is I got to mill a flat up at this end and drill the hole so that I can attach it to my current puller. But I think this is going to work. Okay, now that I've made both of my jaw ends and tested the fit, I've now reinserted one of them, and I've got it actually turned so that I'm 90 degrees to the face of the jaw. And I'm going to cut a flat, and then I'm going to rotate this over 180 degrees and cut a flat on the other side. And that's going to be where I'm going to end up drilling my hole for the two links on the jaw puller to bolt up to. So I'm actually just going to eyeball this. How do I know that I'm 90 degrees to the face? Well, I eyeballed it. Looking down from this end, sighting down this end, looking at the flats that I already cut on this end, and seeing how close I can get them to parallel by eye. And it looks pretty good, because this isn't going to be I don't need that level of accuracy where, you know, if I really, really wanted to know, then I guess I would have to figure out a way to maybe indicate that face and make sure that it's actually, well, it would be, actually that's a interesting exercise in working out a problem there. But I'm not going to worry about it right now. Well, I could mount this in a super spacer or a spin indexer or something along those lines, and I could mount it, indicate the face so that it's level, and then rotate it 90 degrees. I could do it that way, I guess. But for my purposes here, this is going to be good enough, and I'm even going to just eyeball that I'm at the edge here with this cutter, and I'm pretty much over the top of it, so I'm going to turn it on and bring the cutter up. Bring the cutter up so it touches off. It's right there. That brings up an interesting point. Actually, I want to figure out how much I want to take off on each side. Alright, so I want the tang that's going to be left behind that I'm going to drill through to be about the thickness of this piece right here. So I already measured, this is 800 thousandths, give or take. Minus, this is 425. 375 thousandths is what I need to take off, but I need to take that off on both sides, half of that. Let's just make it 380. And half of 380 is 190. Correct? Yes. And I'm not going to worry about the whole climb milling, conventional milling. I want to flip this over so that I end up actually taking a cut like that that's going to end up being parallel to that. Now, again, I'm going to eyeball this because this is not critical. And actually, I think I'm going to take this all in one cut. This is such free machining steel. I'm having such an easy time with this. I think I could take the full 190 thousandths cut in one pass. It's still pretty hot.